Okay, we're gonna do this snowball problem. So we throw the ball at 25. And so what you want to say is VI equals 25, right?
Yeah.
Bless you. But there's another VI, isn't there?
0.
Ah, Elena, good. Golf clap for Elena. Elena, what type of velocity is 0?
It's like what velocity?
Yeah, this one's 25, but there's also a VI that's 0. Which one is, what's the difference between these two? And how can they both be two different numbers? Ty.
You have your x velocity and y velocity.
Oh, okay. When Ty says x velocity and y velocity, what does he mean by that?
Horizontal and vertical.
Brigitte?
Horizontal and vertical.
Good. Put your arm like this. This is horizontal. What's vertical? Like this, right? So we say this is x going across and this is y, right? You guys remember that from Math 8 or whatever? So I would say this is VIY is 0 and VIX is 25. Why do we need to separate the x and the y?
Because it has one is dropping and one is going forward.
Ah. So Gordon says the VI0 is for the drop, the vertical part, and the 25 is for the horizontal part. Now, but it's just one snowball, right? So why would we need to separate out the vertical velocity and the horizontal, Jeffrey?
Makes it easier to analyze the distances and speeds.
Okay, yeah, for sure. It makes it easier to analyze.
Separates the problem.
Costa, what makes this snowball fall?
That is 20 meters up in the air.
No. If it's 20 meters up in the air on a space station, it won't fall.
Ground.
Good. Gravity. Lucy, what direction does gravity pull? Down. So is this velocity going to change, Romina? This one?
Yeah.
If I'm holding this, what's its velocity right now?
0.
Does it change?
Yes.
Yeah. So, Romina, does the 25 change or does the 0 change? The 0 changes, right? So vertically, because gravity's pulling straight down, this snowball's velocity will change vertically. But will it change horizontally?
No.
No.
Is gravity going to accelerate it?
No.
No. Callista's shaking her head no. And that's correct. So now, in real life, it's going to get slowed down a little bit, right? What's going to slow it down? The air. But we live in Physics 11 land, and in Physics 11 land, there's no air. So we don't got to worry about that. It's just going to go 25 the whole way. But vertically, it's going to fall and accelerate downwards at what rate? Good. Negative 9.8. And that's why if you throw something and if you drop something, they land at the same time. So for us to find the time it takes to get to the ground, all we need to do is pretend that we're just dropping it straight down. Okay, so we know VI, so this is the vertical VI. What's my acceleration vertically? Negative 9.8. And this one we're going to save for later. So we're going to do the vertical part first. What else do we know vertically? We know the distance, right? What's our displacement vertically? Yeah, well, it's 20. The thing's 20 meters high. Why do we say negative 20? Good, Dale. Very good. So this snowball at the end will be 20 meters lower than it was before. So this is going to be negative 20. Okay, and then what are we looking for right now? Time. Good. Anybody know which formula we can use for that? We can use this one, right? This one looks complicated, so it's kind of scary, but we're gonna make it simpler. How do we make it simpler?
T equal vi plus minus square root
We can cancel the VI
Yeah.
because it's 0.
Right, so if we say VIT plus half AT squared, the VI vertically is 0. So how Shang? What is VIT? Good. This part is gone, right? So if we just have half AT squared, but we want to solve for T. Hey, can they see me in the video?
Yeah, you're kind of at the end though.
I don't have.
They can see your hand.
That works.
How do I solve this for T?
They still see your hand.
What?
Now you can.
No, they
Yeah,
can
they can see you.
T. Who's the?
As long as they can see this part.
Oh yeah, they can see the board. Easy.
They don't need to see me.
Oh no, I'm sure they do.
Okay, so Elaine says 2. So if I want to get rid of this, I multiply by 2, right? So I'm going to have 2D. How do I get rid of the A? Good, it's being multiplied, so I divide by A. How do I get rid of the square root? Or sorry, the square. I gave it up. So this would be 2 squared, but we're going to square root both sides. And so I'll just erase this square because that ends up as T. Okay, so that's my formula. And my D is 20, so that's about 40 over about 10 is 4. Square root of 4 is about 2. Right? Did you get, is that right?
Yeah, it's 2.
Did you get 2? Who got 2 around 2 seconds?
Isn't it 2.04?
Yes, 2.04 is great.
It's a bit over that.
Yeah, good question, Iman. Let's reiterate. We have 2 VIs, right? So if you're thinking, wait a minute, you're throwing it at 25. How can you just say that VI is 0? That makes no sense. What we're doing is we're saying the ball is moving forward at 25. So my VI in the X direction is 25. But vertically, it's 0. And because gravity only acts in the vertical direction, gravity has no power over what happens in the flat way. It only has power over what happens vertically. So vertically, this has a velocity of nothing because it's only going flat. So we use this as our VI because this velocity is all changing because of gravity. Does that make sense? Kind of, sort of. It's a little bit of a mind bender, but once that clicks, then it'll make sense. Okay, so we got a time. What was it? 2 seconds? 2.02. Okay. Oh yeah, I can't show you this. That's the answer. Okay, now that you have the time, try to figure out if we hit the person down here.
What do you mean by vertical over the formula?
Say that one more time, Lynn.
What do you mean by the vertical over V equals VIT? That formula, what is vertical?
Oh, vertical means this. Straight up and down.
What do I write
The y-axis. What do you write here?
there?
You can write vertical, or you can write y-axis, or you can write gravity, or it's just a description.
Okay, got it.
Just a description. Basically, we know the acceleration vertically, right? It's always the same. If you're on the Earth, it's negative 9.8. But if you're going to use these formulas and use the acceleration as negative 9.8, you can only use the vertical stuff. So you can only use the vertical displacement, and you can only use the vertical VI.
I thought you put that formula as a denominator, that's why I was confused, but I get it.
Oh, this is just like a section
Yeah, that's
title
why I was like,
kind
what's
of
going
thing.
on?
It'll make more sense because now we're going to do horizontal over here.
Now they can't see you.
Yeah.
Right. Okay, I'll switch them again. Okay, you got a time?
Yeah.
Do you guys understand why the time is the time? Time is sort of. If I asked you to find the time it would take if I just dropped something straight down, do you see that you could use that formula to find the time that it takes to fall?
Yeah.
That's all you're doing. That's all you're doing. If you throw something straight horizontally, it will take exactly the same amount of time to fall as if you just dropped it straight down. Okay, so you just VI is 0 and you know your displacement and you're just solving for time. That's it. What happens horizontally? Is there acceleration on the flight? Well, in the real world, deceleration causes you're right, but there's no air here.
So it's just keep going for
It's just exactly the same velocity forever. Okay. So if there's no acceleration, do any of these three formulas not have A?
No.
They all have A, right? So we don't need those ones. What's the simple velocity formula?
VU equals d over t.
So for the horizontal, we can just use our constant velocity. V is d over t. So this is constant.
We use it because we don't know the acceleration.
Yeah, we use it because acceleration is 0. So actually, if you look at this one, if you made A 0, what do you have left?
Yeah.
VF equals VI, right?
Yeah.
It's the same. And if VI equals VF, then it's just distance over time. That's all you need. How long is it going to take for this to hit the ground? Do we know that number? Yeah, we just solved it, right? So we actually know this t already. So what are we going to solve this for? We're going to solve it for d, right? And we're going to see if that answer is close to 50. So go ahead and try. This is, we could say, is vx. And this is dx. So if we solve that, Jack, do you know how to solve this for d?
Yes, d equals v.
Thank you. T equals d. And now which velocity are we going to use now though? Is it 0 or is it 25?
25.
This time we're going to use 25 because now we're looking on the flat. What was the time? 2.02?
2.03.
2.02. And so we got
50.5.
pretty close to 50, right?
So a few hater got hit by that still.
Yeah. Equals d.
Because they both have long hair.
Yeah, it's pretty close. Actually, it's actually better because if it was 50, it would land at the person's feet, right? Like right where they're standing. So we're probably gonna hit them. It's probably gonna be good.
I have a question.
Yeah.
Before you talked about how the pedestals have the same acceleration if you're moving forward or moving down.
Yes.
But then but we're saying that acceleration is 0 for horizontal.
Yeah. Horizontally, there's no change in this velocity because it's only gravity pulling down. So the velocity change in both of those situations, dropping and throwing, so long as you throw it straight flat, the acceleration vertically is exactly the same. And so you're going to take the same time to hit the ground. Yeah, the vertical.
But the horizontal, there's no horizontal.
Horizontal, there's no acceleration. Yeah. So the only difference between dropping and throwing straight is that this one had a horizontal velocity to start with, and this one did not. Okay, so let me ask you this. If, let's look at our cliff here. If the thrower threw at 5 meters per second, would it go the same distance?
No.
Would it have the same time in the air?
Yes.
Yes, it would have the same time in the air. Why?
Because
Ty?
Because it falls at a constant rate, regardless of if you just dropped it or threw it. So it doesn't really matter how much you change the speed. You can throw it at light speed. I mean, it would go off the planet.
Well, you
but-
can't throw it at light speed. As a
but it
physicist, I
would-
have to
it would hit
interrupt
the
that one.
ground At 2 seconds.
You could throw it really fast, right? Yeah, Danny.
The y acceleration is always the same.
Good. Excellent. Gravity always accelerates downward the same rate. So if I throw this at 5, where is it going to end up? Will it go past the snowmobile or before? Oh, we're not at the snowmobile yet. Will it go past this person? It'll go before, right? Because it's going slower, so it'll land here. But if you threw a 5 and a 25 at the same time, they would both land on the ground at the same time, right? It's just that this one would cover less horizontal distance. What if I fired a gun? Really powerful. Okay, it's faster than the speed of sound from here. Now, same height cliff and everything, and you threw the thing, and somebody dropped one, and I fired my gun. Would they still land at the same time?
technically no.
Yeah.
Yes, they would land at the same time. Now, in the real world, it's going to be a little different because you got air and the wind and stuff. Not the curvature of the Earth. No, we're not going to worry about that. The Earth's pretty big. On a flat surface, if you negate the curvature of the Earth, Jeffrey, and there's no air resistance, they will actually land at the same time. But what would you say about the horizontal travel of the bullet? It would go a long way,
It would
right?
go long.
Because if it's going at 1,000 meters per second, well, you tell me, if I shoot a bullet at 1,000 meters per second, how far is it going to go? Good. Golf clap for Gordon. Tell us how you got that.
This is only like after 2 seconds it will land, so like 1 second it will middle and then 2 seconds it will land.
So what Gordon just did in his mind was he said, it doesn't matter how fast it's going horizontally, gravity will accelerate it the same vertically. Bless you, Wendy. But the bullet's going really fast, right? So it still has the same amount of time until it hits the ground. It's just going to go a farther distance in that same amount of time. And so it still has 2 seconds, but if it's going 1,000 meters per second, it's going to go 2,000 meters in those 2 seconds and then land on the ground, right? Who kind of understands that? Okay, turn to the person beside you and explain this problem to them.
So basically, acceleration